Hello everyone. Today we are going to look at another LeetCode problem, which is category of art, where we need to merge BST into single BST. So BST is basically binary search tree. So we know that binary search tree is something where everything in the left is less than the root node, and then everything on the right is greater than the root node. That's a basic property of the binary search tree. Now let's look at the example here. So it is given that this is one binary search tree. Oh, this is one binary tree, second tree, and third tree. This is a list of input that we get, and then we want to merge them to create a final tree, and then validate whether that tree which is created after the merge is a valid BST or not, valid binary search tree or not. So now if I look at this example here, so I have drawn node here. So how we can do a merging here? So basically, if I look at the first one, the root node is 2, and then second tree the root node is 3, and the third the root node is 5. Now out of these three tree, I need to determine from where I need to start the merging. For that, the one thing we need to see is the which one the root node is not the leaf node of any other tree. In case of this root node, 2 is a leaf node of this tree. In case of this root node, it is a leaf node of this tree. But in case of 3, it is not a leaf node of any other tree, right? So my starting position will be this particular node. This is my start root node from where I'll start doing the merging. Now once I identify what is my starting position, starting root node, I can do further merging. I can then after that we can apply the merging of the binary. Now let's say if I try to merge this one, so 2 matches with here, so I'll add this node here basically. So this is one node, and I'll delete this particular tree. So this node is this particular binary tree is merged. Now the remaining tree is 5 and 4. In this case 5 matches here. So I'll update this tree again, this root tree, and then move sorry, I'll just delete this one, erase this one. Okay, now it's on the left hand side, so I'll move this one here. Now if I validate this binary tree, so everything on the left, this piece is less than 3, and everything on the right basically is greater than 3. So this means this is a valid BST. Okay, so this is the logic here. Now if I go back to the code section, so what I need to do is, in order to determine, as I mentioned, what is the starting point of my uh, root tree, out of these three, what is the starting point? So I need to determine this. So what do I do is, basically I identify all the leaf nodes first. So 1, 2, 5 and 4, and out of these leaf nodes I try to identify which one is not the root node of any other tree. So if I look at 1, 2, 5 and 4, so 2 is already root node and 5 is already root node of another tree. So these two cannot be my starting point. So starting point can be this node. So I'll identify as a root node, root tree, and assign into this particular root. So this is my starting point. In case if I don't find any tree, I'll just return that and empty. Now in the list of remaining trees, basically this is 5 and 4 and 2 and 1, I'll put it into this particular tree. I'll just append it because now I want to use this list for the merging purpose. Now from this particular list I am preparing a key value pair. So why I need this? Basically just for the searching purpose. So once I have this let me just clear it up a bit, it's messy. So basically what I want to do is create a dictionary that will hold the root node value and the and the corresponding tree. So when I am creating the, so once I know that this is my root node starting point, now I'll create a dictionary for 2 1 2 and then 5, this tree and this tree. So in the dictionary, what I'll have is, let's say, uh, 2, let's take a, so 2 is going to be my starting, and then key and value will be the tree of 2, and then next is 5, value will be tree of 5. So basically the entire tree here, right? I'll tell you why I prepared this particular key later on. So I got this particular dictionary which holds basically 2 and then the tree for the 2, and then root node 5, and then tree for the 5. Okay, now I'll have a helper function which does the merging for me, which basically traverses the tree and then tries to merge it. Now if once I call the helper function, in this helper function I'm passing the root tree, which is my starting tree, which is this one, and then dictionary which holds this information, the key which is root node value in the tree, and then again 5 and then entire tree. Now if I try to check whether the root value is in the dictionary, now when I start the tree traversal, I am at this particular position, which is 3 node, right? So 3 does not matches with any of the dictionary values, so I'll just ignore it, and then I'll do the left tree traversal and then corresponding right tree traversal. So once I go to the left tree traversal, I reach here, which is 2. Now root value is 2. Whether root value is present in dictionary? Yes, because my dictionary holds 2 and 5, right? And then 2 is present in the dictionary. It is present in the dictionary. Then I'll extract the tree and then assign all the left node to this node and then all the right node to this node. And then I pop up the dictionary. I'll remove this particular tree out of the dictionary. Now only remaining value is 5 and 4 in the dictionary. Again I'll do the further traversal. So now it goes to the right one, it again goes and again perform the same operation as I explained for 2. It finds that there is a match of 5, then it will assign the left node of 5, which is 4, to this node, and then right node, in this case there is nothing, to this node. If it is there, it will assign, and then pop up the dictionary. Now all the tree, this tree and this tree has been popped up, so this ideally this tree, my dictionary is empty, and also tree traversal is ended. There is no further node to travel, right? So finally the root that I get, which is updated tree, I need to check whether it's a valid binary search tree or not. So I have a very common logic to check whether it's a valid BST or not. Based on this function, if it returns a valid BST and also the dictionary is empty because nothing is left in the dictionary, I'll return the final tree as a result. If not, if both the condition doesn't matches, I'll return the null value. So that's what the entire logic is. It's kind of bit lengthy and messy, but this is how it works. In case if I don't find valid BST, for example in the second case, I'll just return none. I don't do any merging after the merging. In case if we, for example here 5 and then 6, so everything else on the left hand side should be less, but in this case 6 is greater than 5, so it's not a valid tree, so it will return none after merging. If I run this, so it will evaluate. Yeah, test cases works fine, and I can just go ahead and submit it. Okay, cool. Thanks for watching this video.